This video will explain the answer to the following question. Please feel free to pause the video at any time or to rewind back to make sure you're understanding everything. At the point on the ground, 46 feet from the foot of a tree, the angle of elevation is 48 degrees. What is the height of the tree to the nearest foot? Two important vocabulary words to pay attention to is angle of elevation and height. The angle of elevation will always be the angle looking up from the ground. So you can see it posted right here. It is our input angle in this question. Meanwhile, the height of the tree will always be perpendicular to the ground. So since we're looking for the height of it, they've labeled it with X since it's missing. The only other piece of information they gave you that's important is they told you that the base of the tree is 46 feet away from the point on the ground where we are looking up at from. And that is labeled right here on your diagram. So the two questions that are going to help you address this problem, the first one is, which trig formula will I use? So, ka, or toa? In order to determine that, we're going to have to label our triangle. I always start first by labeling the opposite side. So go to the input angle and go across from it, and that opposite side happens to be the height of the tree. Next, I always label the hypotenuse. You always go to the right angle, which is where the height is perpendicular with the ground, and go across from it, and that will give you your hypotenuse. And finally, your adjacent side, you go back to that input angle, but you go next to it this time, and that happens to be the distance the tree is from the point you were looking along the ground. Now, when I'm determining which trig formula to use, I need to remember what all these letters stand for. So when I'm looking at my diagram, I see that my opposite side is the unknown. So I'm looking for a formula that involves OPP for opposite. And 46 is the length of the ground. That is another piece of information I have. So I'm also looking for something that deals with the adjacent side, ADJ. And the only trig formula that has both opposite and adjacent in it, O and A in it, is going to be TOA. So is missing the adjacent, and ka is missing the opposite. So now I know which trig I'm going to use. I'm going to use my tan of my angle is equal to my opposite over adjacent side. Okay? Now, the next question I'm going to ask myself is, am I solving for a side or an angle? If I'm solving for a side, I'm going to be using the regular tan. If I'm solving for an angle, I'm going to be using the inverse tan. Since I want the height of a tree, I can tell that is labeled on the outside of my triangle. I'm looking for a side. So I'm going to be using my regular tan. So we know that the tan of the input angle, which is 48, is equal to the opposite over the adjacent. I just need to fill in my information. Opposite is X and adjacent is 46. We can solve this by making proportions. Always put your trig identity over 1 and do cross products. X times 1 is X, and 46 times tan of 48 is actually something I'm going to need to use my calculator for. Before you go crazy, please make sure that your calculator is in degree mode. You can check by hitting the mode button on your calculator and checking the third row to see if it says radians is highlighted or degrees is highlighted. After you do that, please plug it into your calculator, and when you do, you'll notice that after you round your answer, the answer is going to be 51 feet.